Welcome to physics class, and this is Doppler Effect. So with Doppler Effect, we are actually dealing problems that has to do with the motion of sound and its frequency and wavelength. So reflection of sound waves enables birds to hunt. The sound wave produced by bird has a frequency of 22k kilohertz, wavelength of 1.5 multiplied by 10 to the power negative 3. So calculate speed of wavelength through the air. That's what they want. Now we know that constant, whether constant speed of sound or light, is frequency times wavelength. Now velocity, constant speed, constant. This is the constant speed there, which is v for sound. Now if we keep it c there, it's going to be for light. So velocity is frequency, that's our frequency, multiplied by wavelength, that's our wavelength. So that means now we have 2. Remember that kilo means 1,000, so we're going to have 222,000 Hz. So multiply by 10.5, multiply by 10 to the power negative 3. So that can be rewritten as 2,000,000 multiplied by 10 to the power 1, multiplied by 1.5 divided by 10 to the power 3 is 1,000. So the 3 zeros cancel each other, and then now we have our speed as 222 multiplied by 1.5. So 222 multiplied by 1.5. What do we get? We had 333. So it's 333. So 333. So that's speed. So the speed is meter per second. Remember, Hz, it's per second. So a station bird sends out sound, receives the same signal, and then reflected from a moving moth at a frequency of, now the frequency is 230, stationary bird. Okay, so that's the stationary bird. So we're talking about the bird there. So the bird is the one emitting the frequency, not the moth. So frequency of the source, that's 222 kilohertz. So it's 222 kilohertz there, 222,000. And then we have frequency of listener, that is 230. So 230. So there's been an increase in the frequency. Okay, so the increase, remember, it bounces back, so it's coming back. I assume nothing interferes, the speed has to be the same. So frequency of listener is greater than frequency of source. So that way, now the bird is coming towards. So as it comes towards, the sound pitch increases. So that's why it's towards. So calculate the magnitude 5.2.2, magnitude of velocity of the moth, assuming that the velocity is constant. So we need to calculate the velocity. So we need to calculate the velocity there. So velocity is v plus or minus frequency of source, and then the velocity there. Remember when we calculated the velocity, so towards there, and velocity of source, look at, let's say, stationary, so which means velocity of source is 0 because it's not moving. Stationary means it's not moving, so 0 velocity for that. So coming there, velocity is 0, and then we know that frequency of listener is plus VL over, so we write the original equation, plus V is 0 multiplied by frequency of source. And remember, we calculated the V there. If velocity of listener is 230, so we have 230 kilohertz, so that will give us 230,3 there, multiplied by 10 to the power 3 for kilo. And then we also have velocity, so that's the velocity of listener is 333 plus velocity of velocity of speed of sound 3,333. Velocity of listening is what we want, multiplied by frequency of source, that's 222 multiplied by 222,000, so 222,000. Hey, so we know that's multiplication on both sides, so that means divide by 1000, 10 to the power 3, they cancel out. So we have a simplified version, so we have to 230.3 multiplied by denominator 333, so that we have 222 multiplied by 333 plus VL. So you just simplify the given equation. So given the calculator, 230.33 multiplied by 333, 76689.9. So that's going to be 76689.9 is equals to 222 multiplied by 333. 322 multiplied by 333 gives us 973926. Okay, so 222 multiplied by VL, so that's going to be 222 VL. So that's 222 VL. So therefore we have VL is equals to 76689.9 minus 73926 all over 222. Okay, so that gives us an equation whereby 76689.9 minus 73926 divided by 222 gives us 12.45. So it's 12.45 meter per second. We just write it vertically down, so it's going to be 12.45 meter per second. So that's the speed at which the moth is actually moving. So remember, the moth is the velocity of the listener. So that's it. Now we have the so thank you so much for watching. This is Doppler Academy, and don't forget to follow, subscribe, much appreciated. Thank you.